Okay, so let's go ahead and get started. There's a couple of seats up front if folks want to come up front. I'd like to thank everybody for joining us this morning for the first session on the last day after the party last night. I welcome all of you and appreciate your enthusiasm to come on out this morning. Today we're going to be talking about leveraging Hadoop 2 inside of HDInsight. My name is Matt Winkler. I'm a program manager on the HDInsight team. So quick show of hands so we can do a bit of a level check in the room. How many folks are using HDInsight today? Okay, cool. Thank you very much. How many folks are using Hadoop today? Okay, cool. North of 50% of the room. How many folks are using Hadoop in a cloud today? Be the HDInsight folks. Okay, so everybody else is doing it on-prem? Okay, cool. All right, well, what we're going to do today is talk a little bit about some of the enhancements that we've brought into HDInsight as we've brought Hadoop 2 inside. And then what we'll really do is dive into one of the more interesting capabilities of Hadoop 2, which is the performance enhancements which have happened to MapReduce, and then we'll start talking about Yarn, because that's a topic that most folks are fairly interested in when we talk about Hadoop 2. And Yarn is really kind of the showcase feature that a lot of folks will talk about inside of Hadoop 2, but really there's a nice set of improvements around scalability and reliability of the core MapReduce and HDFS infrastructures. And so that means simply moving to Hadoop 2 means you're going to have generally more performance for your MapReduce jobs. You're going to be able to scale better, and you're going to be able to handle failure modes more easily. Important thing to note, so when we talk about HDInsight, we version of the cluster that we put out. That then expands into a distribution of Hadoop, which then expands further into all of the individual pieces and parts and components. And the nice thing about that, to keep it plenty simple, is each one of those is versioned separately, and each one's versioning numbering scheme is governed by a different organization. And so each of the Hadoop projects all version themselves based on what the committers of those projects decide. Then the owner of the distribution decides they'll wrap those up and they'll package them and they'll version it something. And then we've got to package that inside of a cluster. And so we version the cluster. So when you see HDInsight version 3 clusters, these are the ones that I'm talking about that include Hadoop 2. The other thing that happened inside of the Hadoop 2 timeframe is that we've made some substantial performance improvements to Hive. This is work that was started in the Hadoop, in the HDP 1.3 timeframe for Hive 11, where we introduced a new file format for Hive, and then inside Hive 12, we've actually started to land some improvements to the query optimizer, being able to push predicates down when we run the jobs. And what all of this means is that we're able to run Hive jobs substantially more in a more performant fashion. Obviously, you can hand wave lots of different types of performance benchmarks. These are ones that I think are kind of interesting, which shows kind of the improvements that happened from Hive 10 to the work that was done in Hive 11, and then in the work that was done in Hive 12 is all the way over on the right. And what you can see is we're continuing to see fairly substantial performance improvements. And this is going to continue to improve with a project called TES that you will see light up in the next version of HDInsight. But this is all about taking the performance of Hive and really, really bringing it down, both with improvements into the core Hive engine, as well as improvements into the file format. So we'll do a quick demo. So for all of the folks that have an Azure subscription, well, let me start. For the folks who don't have an Azure subscription, I'd encourage you to get one. For everybody who has one, you can follow along at home in order to do this. So I'm inside the Azure Management Portal. I'm going to walk up here and say, I would like to create an HDInsight cluster. We've got two modes, Quick Create and Custom Create. Quick Create is just very quickly take all the defaults and go. Currently, this does not deploy a Hadoop 2 cluster. You have to opt into that. We'll be switching that over shortly. And so I opt into Custom Create. We'll call this mwinkle Hadoop 2. Let me zoom in on that, sorry. Call that mwinkle Hadoop 2. I can pick as many nodes as I want. And then here, what we'll need to do is pick HDInsight version 3. We've gotten some feedback that it's not really clear from our version numbers what are contained within this, so in the next update of the portal in the next couple of weeks, we'll expand this, so we'll actually include the Hadoop version alongside these version numbers, so it's a little more clear. But I would just pick Hadoop HDInsight 3, pick which data center I'd like to deploy these into, and then I'm off to the races after this. So when I've got my cluster up and running, there are a few things that are a little different. And so I'm RDP'd into this cluster. Let me first back out here. I can certainly still program against this with PowerShell. From that perspective, nothing has changed. I can go ahead and configure the types of jobs that I'd like to run, submit them, whether those are pig jobs, hive jobs, MapReduce jobs. Here what we'll do is we'll kick off TerraSort. But if we go and look at the cluster, what you'll see here is this looks a little different. For folks who've been using Hadoop before, when you go to the job tracker webpage, it's gotten a sizable facelift for Yarn. Because really now what you're not just looking at the job tracker, which is responsible for running MapReduce jobs, you're looking at the Yarn application, the resource manager page. And so if we refresh here, you'll see that job that I just submitted is submitted and is up and running. And the interesting thing about this is that this allows each of the different types of applications that are running to have their own UX for this in order to be able to see, hey, how many maps do I have running, what controllers are running, which containers are running, and those types of things. So this is a little different. If you're familiar with the job tracker page in Hadoop 1, this is not too different, but the nice thing about this is as we start to bring in other application types, we can manage them from here. The other thing that I'd like to show is just something from that Hive work that I talked about. And I just want to give an example of why the file format is kind of interesting. And so here I've got a series of web logs that are emitted, or IIS web logs that are emitted from Azure websites for the blog site for somebody at the company. And what these guys do is the Azure websites will write out every hour, it'll write out all of the IIS logs into BlobStore. This is pretty cool, and so I've got 2.7 gigs of log files here in a number of files. I did a very simple transformation, which was I created an external table. Let me zoom in on this. I created an external table in Hive, and all that an external table is this is going to look, this will have columns for all of my entries in my IIS logs, and it's going to be sitting inside this file directory. I took that, I created a second table, websites logs ORC, and I'm storing that as an ORC file. So here's where I specify what type of serialization format that I want to do. And I'm going to stick it inside this ORC example directory. And then I'll insert all of my rows. I'll insert from one table into the other. What this will do is this is transforming from raw text files, 2.7 gigabytes of those, into ORC. And if we go look at that ORC directory, go look at the ORC directory, when this guy pops back, there's about 250 megabytes of files here. And so ORC file is not only compressed, it's also a pretty optimized column store format. So what we do is we're pretty smart about where we put the columns so that they can be easily batched and pre-aggregated. And what that means is for a ton of aggregation operators, sum, average, kind of a lot of the types of things that we do in data warehousing queries, you can actually be very efficient about performing the calculation on the values that are within there. And so your query time then speeds up dramatically. So you get this very nice benefit of now I'm at 1/10 of the storage, and my query will actually run substantially faster. Again, a bit of a hand wave for for a number of classes of queries. Not every query will be faster. Okay. So let's go on a little walk that introduces why Yarn is interesting. And if we think about Hadoop, in the beginning, there was MapReduce. Right? Hadoop was really two things at its birth. One was a distributed file system, and the other was MapReduce. Put quite simply, it solved two problems. How do you store a copy of the internet somewhere, and then how do you ask it questions? And MapReduce is fundamental to Hadoop. And if we think about it, we can look at it from a functional definition perspective, where we read in a series of lines and we emit key value pairs. And then what we do over lots and lots of nodes is we take all of the values that are associated with those keys, and we pass those into the reduce function. And this is how we express an algorithm. This is a very clean way to express it because it's innately parallelizable. There's no state held between any nodes. No nodes need to communicate. And so if we can express an algorithm this way, it allows it to be distributed in a pretty nice fashion. So what I have over on the left here is this in JavaScript. And if we want to do word count is the hello world of Hadoop. I'm going to use the power of the 100 nodes I just created to count all of the words in the quick brown fox jumps over the lazy dog. And so what I do is I process that line. In the map phase, I go on that line, I split it, and I emit keys and values. The keys are the words because I'm interested in counting those. The value is simply 1 because all I need to do is sum those up. The shuffle happens because I've got 100 nodes that have counted all these words, and I need to make sure that all of the values for any given key land on the same node for the reduce function to be called. This is how I can perform whatever math I need to perform in the reduce function. And so here, the only one that has more than one value is the, so we do a shuffle to make sure that the is combined with the two values there. That gets passed into the reduce function. The reduce function is very simple. It just walks over that collection and adds them up. And now we have the values that we're going to write out. And so now we've able to scale this out to a whole lot more data than just that one sentence with the exact same programming model. Now, the challenge with this really comes in two ways. So the first is, for word count, this is a pretty easy thing to explain. We can all figure this out. There's no rocket science here. But as we start doing things which we think of typical analytic data warehousing queries, MapReduce starts to get very hard very quickly. Expressing a join in MapReduce would take a fair amount of time for the rest of the session in order to walk through what needs to happen there. The other thing is that the programming model is fairly verbose. And so in order to do this, this is the kind of the core, the root of Hadoop. Programming against the MapReduce APIs, there's a lot of places to get something wrong here. And a few things to point out here. Can't use the mouse on that. A few things to point out here are, in order to properly serialize, you can't use the default types in Java, so you don't use ints and strings and those types of things. I have to use long writables and text and int writables and a bunch of those types of things in order to create the value 1, which is what's happening on line 30 there. I can't just say I'm creating an int of value 1. I have to create a new int writable of 1. And so there's a lot of ceremony to this programming model. And so naturally, we did what happened in the Hadoop ecosystem is what tends to always happen inside computer science is that we looked at it. Some folks can figure it out. Not a whole lot of other folks can figure it out. How are we going to fix that? Well, let's enter some abstractions. Right? MapReduce is a great foundation, scales really, really well. Let's start building up on top of this. And I'll talk about 3 abstractions here. The first is Pig. The Pig project is great for processing unstructured data. One of the tenets of Pig, it's worth going out to the Apache Pig site and reading the guiding principles for the Pig project. They're kind of humorous. One is that pigs eat everything. Another is that pigs are domesticated animals, so pigs should be able to serve you as you want to go do your data processing. And what it allows you to do is have a data flow language. And so what I'm doing here is I'm going to process some web logs. A few things to point out. This is where I'm specifying all of the various columns and data structures that I have. And then the programming model for Pig is almost that you've got streams of tuples that you're operating on top of. And so when we get here, what you can see is for each of these values, what am I going to generate? I'm going to generate a count. I'm going to call some functions of sum, an average. I can define UDFs here so I can build my own custom logic. And then when I want to write that out, I just say, hey, I'm going to store that out, and I can go write that out to the file system. This is pretty cool because what happens behind the scenes is that this builds up a directed graph of all of the various pieces and parts of every time I'm doing something equals something. That's an element that I have to figure out how to compute. And as I build a very long Pig script, because I don't just want to process one table and output one table, I'm going to do a whole series of reports. And the compiler can look at that directed graph and say, oh, I'm actually going to reuse the output of this job 5 times, so I only have to run it once. And I'll just keep that output around until all of the 5 dependent jobs run on it, and then I'll get rid of the output. And this is something that if you were writing this in MapReduce, it would be left as an exercise for the reader. So Pig is cool, but if you go and talk to a lot of folks who are doing data analytics, they've never heard of it before. It's specific to the Hadoop ecosystem. It's not really like just about anything else I've seen. And so the other thing that was very, very important was to get to SQL. And so this is where Hive enters the picture. And so Hive, everybody who can speak SQL, you could come up here and we could write a Hive query right now. The only thing that's a little different about Hive is in the DDL, it gets a little more physical at times. And so if you look down at the bottom here, you see I'm specifying a lot more about the format and the type and how this data is going to be written down. So it looks like normal DDL. Here's the logical view. But then I have to get very physical down at the bottom there. But then the benefit of that is that it just lets me write SQL queries. So all of the things I want to do with SQL, all of the relational operators, all of the joins, all of those things work. My personal favorite, cascading and scalding. So cascading is it's an attempt to bring a modern API on top of MapReduce. So the nice thing about it is it's a JVM experience. So you don't have to get outside of Java. The challenge with Hive and Pig, if I want to write a UDF, I have to go create a UDF in Java, and then I have to bring that into Pig, and I have to use it there. The nice thing about cascading is it's just the JVM, so I can just stay in that the entire time. Scalding is a project that then came from Twitter. Twitter liked cascading a lot, but they wanted to be even more productive, so they created another abstraction on top of this, and it's actually a Scala DSL on top of cascading. And for .NET folks in the room, this should look fairly familiar. If you squint at this and hope that Anders isn't running around the building, this looks very similar to Link. In fact, they were quite inspired by Link when they went down the path of creating this. And so if we go from that kind of lots of ceremony MapReduce to do word count to this is much more succinct and much more easy to understand. But at the end of the day, all of these things bottom out at MapReduce. So you can think of MapReduce as the set of opcodes to execute on the processor that is my Hadoop cluster. And so just like anything that spits out opcodes, we need a compiler. So Pig has a compiler, Hive has a compiler, Cascading has a compiler. And what it's doing is it's taking whatever graph, whatever is passed into it, parsing SQL, and figuring out this is the most efficient set of MapReduce jobs to go execute on the back end. But this actually causes some problems because, and so let me just show an example of this. So this is the word count in Scalding, and what you can see on the right is essentially the logical query plan that bottoms out at MapReduce. The blue box on the top encompasses the map phase, the red box encompasses the reduce phase. For word count, again, this is fine because you can express it as just a single MapReduce task. Once you start doing something a little more fancy, when you want to start doing joins and pushing predicates down both sides of the join, this gets very hairy very quickly. And let's talk a little bit about the architecture of MapReduce in Hadoop 1, because this this is the last piece to kind of set the stage for what needs to happen in Yarn. So inside Hadoop 1, there are a whole lot of nodes, and there is one very important node, which is the head node and the job tracker. And the reason it's important is that's the sole arbiter for all of the work that happens in the cluster. I submit a MapReduce job to that. The job tracker turns around and says, OK, I will now go out to the various task trackers, which are running on each of the nodes. So the big blue boxes, just think node or VM. And I will instantiate a task on that node. This is fine to go fan the work out. But then when each of those tasks need to report status, well, what do? They call back to the job tracker. And for a long period of time, this was fine. But then we started getting bigger and bigger Hadoop clusters. We started packing more and more cores into a Hadoop cluster. And we started running a lot more jobs, because a single Hive script can go spit out 10 MapReduce jobs that need to run. And so suddenly, the job tracker became the bottleneck here, right? And so as you would run larger Hadoop clusters, that guy started to spend a lot of time processing all of these status requests, trying to figure out all of the status for all of the various tasks, monitoring the tasks and saying, oh, this one's running a little slow, so I need to spin up a clone of that task on another node. And this is all great. This is what makes it efficient to operate. But as you start to scale the cluster, this starts to become less and less manageable. And so this is where Yarn enters the picture. Yarn really started as first a rewrite of MapReduce, of the MapReduce infrastructure, to try and address some of the problems that we saw. But then it started to be generalized. Yarn, like a lot of acronyms, stands for Yet Another Resource Negotiator. It works. And the mental model to have is that in Hadoop 1, what I showed on this slide, you've got two things that are very tightly coupled. You have the compute model of MapReduce and the resource allocation model of the job tracker. Those two go hand in hand. And what you saw with Hadoop 1 is people started to do really funny things. They would spin up a bunch of map-only jobs that then would turn around and run some long-running process. There's even a project out which will spin up Apache web servers inside of a set of nodes. So if you've got a 500-node Hadoop cluster and you'd like to carve off 10 of the nodes to be web servers, you can do that. But the way you've got to shoehorn that into the cluster is, OK, I will run a MapReduce job that just has no reduced jobs, and the mappers will never finish. And so you can contort yourself and get in there and do that, but it's not very natural. It puts a bunch of overhead in the system, particularly because then you have those 10 long-running tasks that are always reporting status back, but they're web servers. They already have lots of ways to report status back. And so the fundamental thing to keep in mind about Yarn is that it's really a separation of that compute model of MapReduce from the resource model. And so this doesn't necessarily make the underlying model simpler. The next slide I'm going to show has a few more boxes and a lot more lines. But we'll walk through it, and what you should see is that this will make it substantially more scalable, and it will open it up for doing a lot of other interesting things on the cluster. As an aside, it is really hard to do curved lines in PowerPoint, as I found when I started to put this slide together last week. I didn't put it together yesterday. When I started to tweak the slide, I needed to fix the curved lines. But we've changed a couple of words on this slide. We don't have a job tracker and a task tracker anymore. Those are implementation aspects of MapReduce. What we do have is a resource manager and a set of node managers. And this is where we've really split out resource management from implementation of what your job's actually going to go do. And so let's walk through the flow here. What's going to happen is that a client will walk up and submit an app to the RM, the resource manager. One point of clarification, just like service is a massively overloaded term, app is a fairly overloaded term. And so what you will often think about describing, MapReduce is an app that runs on top of the cluster. But also a client will submit an app, which is just an instance of a MapReduce job. And so app is an overloaded term. I'll use it in a couple of different contexts, and if it gets too confusing, just kind of raise your hand, because I'll be saying the same word, but of course it means different things. So a client is going to walk up and submit an app to the resource manager. The app that I submit could be Hello World. It could be word count, right? It could just be the MapReduce job for word count. Now, previously what would happen is that would run on the job tracker, who would say, oh, I know what to do. I've got to go spin up some nodes. Instead, what the resource manager does is it just says, hey, my only job in life is to return nodes. Pointers to nodes, which are just a place where I can go run some code. Somebody has submitted an app, so let me look at all the nodes I've got. Let me pick one, and there's a pluggable algorithm that you can twiddle with if you want to figure out how it assigns that. I will get that slot. I will get, not a slot, I will get that container. Container is just a process that's running on that node. And in that container, I will spin up the app that someone submitted. And so previously, in the case of MapReduce, all of that stuff that was running on the job tracker is now going to run on what we call the application master. And see what we did here, that's no longer running on that job tracker node, that resource manager node. So we now federate that out. There's no one node that runs the application master. Any of the nodes can go run that. So we do that. The app master starts up. And again, now you can think mentally, well, for a MapReduce job, the app master is basically the job tracker. Well, what does that need to do? It needs to get a set of nodes that it can go run tasks on. Great. So now what it does is that application master will turn around and talk to the resource manager and say, hey, I need 10 containers. And you can also specify a couple of things like, I would like these containers to be located on these racks or as close to these nodes as you can place them. Or I need containers that have this much memory. You can characterize that request. And again, that goes into a scheduling algorithm to say, oh, what's the best container to return to this guy? The resource manager will return a set of containers, or just one at a time. And as that application master gets the containers, it then just goes and dispatches the jobs to them. And so now what we've done, when those tasks are running inside the containers, they'll report status back to the application master. And so again, what we've done here is we've really eliminated that as the point of contention. The other nice thing that we've done here is we've eliminated that as a point of failure for jobs that are in flight. Now, obviously, if the resource manager goes down, it's slightly bad, because that's the thing which is going to let you get more nodes. But it makes the problem a little easier to fix, right? Because you can talk about a secondary resource manager or highly available resource manager that doesn't have to maintain all this job state, right? Because all of the job state is kept with the application master or the containers. The other thing that this lets you do is for that case that I was talking about kind of the goofy one about spinning up web servers, that's completely fine in this case, right? Because I'm just going to submit an application that says, give me 10 containers and spin up the Apache web server on those. And I don't really have to worry about, oh, now I'm occupying map slots or anything like that. I'm now occupying resources on the cluster, but I can plan around those, and the resource manager will take care of that for me. Finally, the other thing that this will do is that this really lets Hadoop scale on the high end up from the low thousands of nodes to the high thousands of nodes. And now most folks don't have a multi-thousand node Hadoop cluster running. But what it does do is, as we think about machines getting more dense with more cores being packed in, it means that we're in a pretty good place for the next order of magnitude or so scaling that will happen inside Hadoop. So real quick, I'll go to a demo on this. Any questions about that? It was kind of a whirlwind tour of the Yarn Resource Manager architecture. OK. So we'll pop over here. This is again, that cluster that I've got up and running. And let's see. So I actually already demoed showing the MapReduce job running on here. We'll actually look, and this guy probably completed. So here was TerraSort. Let's go ahead and see what the history of this guy looks like. So you'll see here, now this is MapReduce, just all the same words and terms that I had before in terms of, hey, these are the number of map tasks that ran, these are the number of reduce tasks that ran. I can dive into this and see the status of these guys. And so that's running MapReduce on here. All of this just works. And so if you go and look at what the command line looks like, it's going to just be Hadoop jar, blah, 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 blah. And then that's just going to, all that stuff that I talked about, it just happens for you. So sorry about that. I accidentally kicked off the MapReduce job when I did the first demo. So what I'd like to talk about now are a couple of other interesting Yarn applications. Because what this starts to do is, one, it lets you move away from MapReduce as your only programming model at the bottom. This is kind of interesting for a number of reasons. The other thing that it lets you do is, for apps that are these longer running stateful apps, Yarn gives me a very nice way to bootstrap these into the cluster. And so what you see is there's a set of things which leverage Yarn to do new processing paradigms. Graph processing is a good example. And then there are another set of them which almost just use it as the cluster installer. And so rather than figuring out a bunch of shell scripts to spin up daemons on every node, what you can do is you can actually walk up and deploy a number of other distributed apps. The quick disclaimer on these, all of these are at various stages of development. All of these are at various levels of support across cluster types and distributions, and some of these work on HDInsight right now, and some of them don't. In the fullness of time, they all will. But what you really see with the first two is really that, hey, I've got this interesting app called Storm. Are folks familiar with Storm? A few folks? So this is the project that came from Twitter about how do we make sense of what's going on with the Twitter fire hose, and how do we do complex event processing on, kabillions of tweets that are coming through the system. Okay, so that's one app that I can deploy on top of Yarn. There's an HBase on Yarn project as well. Spark and Shark. So this is from down at Berkeley, the Berkeley Big Data, or the Berkeley Data Analytics stack. Can run on top of Yarn. Giraffe supports Yarn. So Giraffe is the top three really fall into that. I'm going to leverage this as a cluster installer. Giraffe is a graph processing library that's based on the Prigel paper from Google. Graph processing is one of these things that's incredibly valuable to do. If you imagine that you have a social graph of connections, or and you want to be able to mine that at scale, it's pretty useful to do graph processing. It's hard to do on data sets that don't fit on one node. And so the Giraffe project is taking advantage of Yarn in order to bring graph processing on top of the Hadoop clusters. So you can do very large-scale graph processing. Continuing with the theme of everything has to be named kind of silly is the Hamster project. So for folks who are familiar with MPI for doing high-performance computing, technical computing type tasks, this is an effort to put MPI on top of Yarn. And so what that will mean in the fullness of time is that you can take an MPI job and just run it on top of a Hadoop cluster. It's kind of cool. There's a project out that runs memcached on top of your Hadoop cluster. This is interesting for folks who are running Hadoop clusters on-prem, who are looking at, hey, I've got this investment in 500 nodes of hardware sitting here. I'd like to be able to use it for different types of workloads. It's an interesting mechanism to kind of think about carving out part of your Hadoop cluster for that. The other one is Dryad. So Dryad is a research project for Microsoft that gives a link programming model on top of a directed graph under infrastructure. And so those guys, they're at the MSR facilities in Silicon Valley, have actually put up the code to Dryad and Dryad Link on GitHub, running on top of Yarn. And so that's kind of interesting from the .NET perspective. So let's take a brief diversion into writing your own Yarn apps for fun and profit. Just like with Hadoop, you have word count is the hello world. The hello world for Yarn is basically the distributed shell, which is, hey, I've got 1,000 nodes, and the thing I should do on this is, on every one of those nodes, run a shell script. That's the most kind of simple way to kind of show off Yarn. And so what we'll do here is we will just jump over to the Apache repo that's sitting on GitHub, and we're going to take a quick walk through the distributed shell sample application. All of those pieces that we saw previously, we saw the client that knows how to submit the jobs. Oh, sorry about that. Thanks. Just trying to be clever here. So we'll just do it over here. That's fine. So what we'll do here, so this is the mirror of the Apache repo that sits on GitHub, and this is the Hadoop Yarn Applications distributed shell sample. Those things that we talked about previously, the client and the app master, we'll see these here. Now the interesting thing, what you don't see here is a specific type to run inside the container. That's because this one kind of cheats because it's distributed shell. You know what command you need to invoke inside the container, so that's going to happen inside the application master. The other requirement here, you don't have to write Yarn apps in Java. At the end of the day, they've now made it the resource manager protocol is just exposed via protocol buffers. And so anything that can speak protobuf can talk to the RM. So you don't have to necessarily implement this in Java. As long as you've got a protobuf stack, you're good to go. So this is a great sample in that it's pretty verbose and it walks through everything in great detail. It's got really good comments. The downside is all we're doing here is we're spinning up and running a shell script on every machine. And the app master here has about 1,000 lines of code. So this is a pretty low-level programming experience. And if you were to just scroll through here, this is pretty, I mean, we're down at the guts here. I mean, the API here is very, very powerful. The downside to it being very, very powerful is that there's a lot you can do with it. And so, of course, what we see happen, let me just pop back on the slide deck to the right spot. So we walked through, we pointed to the distributed shell walkthrough. If anybody wants to go through it, I'd encourage you to. It's a good code read to do, but it's hard to just kind of say, oh, here's the one spot where the magic happens, because there's a lot of different spots where there's a little bit of magic happening everywhere. My general reaction to that was, yikes. I sat down for a weekend, and I was like, hey, I'm going to build a .NET application master. This is going to be great. Here I go. I'll just, it's Java. I can just kind of squint, and it'll be C# on the other side. And yeah, it took more than a weekend. So we're going to repeat the exact same pattern that we saw earlier in slide 12, which is, hey, I know what we'll do. We will introduce some abstractions here. The first two abstractions, one is called Tez, the other is called Reef. These are aimed, so for the most part, this is an interesting abstraction for folks who are interested in building their own distributed application that does data processing. That's probably a much smaller set of folks than the folks who are just using Hadoop. But what this really is this is a, quote, application framework for complex directed acyclic graph of tasks for processing data, end quote, framework. What it means is this gives me a mechanism to not have to split everything into map and reduce tasks. Why is this really interesting? because there's a lot of scenarios where if I don't have to force things to disk, if I don't have to shuffle things over to another machine, I can get vast performance optimizations. And so where this is really, really interesting is for something like Pig or Hive, for that compiler inside of there, rather than targeting MapReduce, to target Tez. And so what this is how we're going to get the next big set of performance improvements to Hive. And the results we've seen, the team at Hortonworks has a couple of blog posts up on the performance improvements we've seen for Hive, and it's orders of magnitude. It's pretty cool, the way that this fundamentally changes Hive's performance characteristics. There are queries that go from thousands of seconds down to tens of seconds, simply by having this type of infrastructure that allows you to kind of move things around. There's a team at Microsoft working on something called Reef. This sits at a little different layer in the stack. If you were to think conceptually in the stack, this probably sits a little bit below Tez, a little closer to that Yarn API that I showed. This gives a pretty simplified programming model for distributed apps. What I'm showing over here on the right is just the very basic task implementation. And then the other thing that's nice about Reef is it provides a pretty nice set of services for discovering other nodes that are running, message passing, serialization, a number of those kind of hard things when you go to build on top of, build a distributed app that become tricky. So that is out. Again, the source on that is also on GitHub. This one is my favorite. This doesn't currently run on HDInsight. It's Kitten for developers who like to play with Yarn. I don't write these jokes. These are in quotes for a reason. This is just like right from the, if you go to the project pages, these are where these come from. And this is from Cloudera, and it uses Lua. This is officially now the weirdest language that I've talked about in a PDC or build talk in my career of doing them. So now we're showing Lua. The cool thing about this, we'll see if my laser works. Not really. The nice thing about this is that this really focuses on kind of easy deployment of an existing application. And so if you look down at the bottom of the Lua code, this is where you specify the container. I need 3 of them, and oh, what do I want it to do? I want it to run that command of echo hello world. So this is essentially my distributed shell from 1,000-ish lines of code down to 10-ish lines of code. And so what you're seeing here, we're very early kind of in the days of Yarn. So Hadoop 2 GA'd towards the end of last year, September or October or so. We're just kind of starting to see other types of apps pick up, and so we're starting to see these frameworks evolve. If I came back and gave this talk in a year, there'd probably be 3 new frameworks, and one of them is probably not, 2 of them have merged, and those types of things. But I wanted to give a little bit of a flavor of what's happening in order to enable folks to write these types of apps. The nice thing about this is that something like this would make it very easy for you to say, hey, I'd like to spin up my memcached daemons, for instance, or Redis, or whatever you'd like to run on every node. So, hey, what about .NET? I want to show Dryad on Yarn. And so what this allows me to do, so you can check out the links here. I'll tweet them after the talk. This is a research prototype that's been put out by Microsoft Research. And what this allows me to do is write this link code in .NET and be able to submit that and run that on an HDInsight cluster that's running Yarn. And so there's still a lot of work that we'll need to do here, but this is out here, and so this is something for folks who are looking for a way to use .NET to leverage their existing investments, to say, hey, I've got these libraries that do this type of processing, I want to include them. This is a great way to go do that. Just like cascading is kind of nice because it's JVM the whole way up and down, this is nice, it's .NET the whole way up and down. And so what that means is I can walk up and I can define UDFs. Well, here, we'll just hop over here. This is in NuGet. So if you go into a project and manage your NuGet packages. And I have an internal pointer to the MSR share. But if we go and search for Dryad, what you'll see here is sample Dryad link program, also Dryad and Dryad link for Yarn. This will pull this down as a NuGet package. And then what we've got is we've just got this, this programming model. And so what we're going to do here is we're going to pull from a store. There's a little bit of work that I do to put my Azure account, storage account, and keys and those types of things in here. Again, it's Hadoop, so let's count some words. We'll take the collected texts of Leonardo da Vinci and figure out which words he used the most frequently. And then this is just how we'd go do word count if I had a text file locally. Right? I'm going to take it up. I'm going to split that out. I'm going to do a group. I'm going to do a sum, an order by. And again, this is all just, this is link. And then I have to do a little bit of work here to say, hey, how am I going to output this? And if we hit F5 here, this will go spin up. What this needs to do is it needs to package up. It's going to package up a bunch of resources locally. It's going to put those into Azure Blob Storage. And then it is going to submit a Yarn application that knows how to go pull all that stuff down and get it up and running, get the Dryad infrastructure up and running inside the cluster, and then submit the job. So while this is going on, what we can do, the other nice thing is they've put out a set of tools to allow you to analyze a job. So let's see if I can see that job that I just submitted. It may still be packaging up a few things. But if I go in and look at an existing job that's already run, they've got a set of tools for analyzing what happened where in the job. So this is pretty useful from a debugging perspective. If you want to understand what the DAG looks like and understand where things might be happening there, you can do that. And then let's check this. So we should probably be running that job. We'll pop back over into our cluster, hit F5 here, and you'll see here's the Dryad Link app is up and running. This one takes about 100 seconds to go from F5 till when the job will complete. We could certainly get better on that by staging a set of those resources inside storage and a couple of those types of things. But when that's done, so that one is done in 101 seconds. We'll go over here. It's probably this one. Let's open this guy up. So this is the output. We'll open this in Notepad. Ta-da! Leonardo da Vinci is 4,088 times computed in .NET running on top of a Hadoop cluster in Azure. So those bits, you can go download those and play with them. It's kind of fun. So what I wanted to do today was give a little bit of an overview of some of the stuff that's new in Hadoop 2. Wanted to kind of give a bit of a deep dive as to why it's important and how it actually addresses some of these scalability and performance issues. Give a little bit of an overview of Yarn-aware applications, talk about kind of the different models that we have, and then give a little bit of what it would take to write your own Yarn app. I don't think there's a whole lot of folks here who are going to pick up and say, hey, I need to go write a Yarn app today. If you do, that's cool. That's awesome. You know, you can get really far with the set of apps that are already running there, but I think it's interesting to kind of do a little bit of a deep dive into what's happening behind the scenes there so you understand that. You know, go out, grab an HDInsight cluster. If you grab the HDInsight v3 clusters, you can get this and you can play with all this stuff today. So we'll turn it over to questions. I'd like to thank everybody for coming again. There's a bunch of great sessions this time. I really appreciate it that you guys came here. Please fill out the evals. I've got a QR code here. I really appreciate feedback on these things. It helps me get better at doing this, and I really appreciate that. So thank you, and if you've got questions, fire away. Yeah. Fantastic question. Thank you. Thank you, sir. What's the question? When do I think Tez is coming to HDInsight? So we just, in last month, we GA'd the HDP2 package, which contains Hadoop 2.2 in it, and a bunch of the Stinger improvements. What I would say is in the next update to the Hadoop bits inside the HDInsight clusters, we'll have Tez there. That would be when we'd like to do that. I will hand wave. There's probably a marketing guy in here, so I can't say anything about dates. But it's very much, we're very, very much interested in having a great Hive experience, and so we'll definitely put that there. Other questions? Anybody on this side of the room? No? OK. Oh, over here, yeah. Yeah, so if you wanted, so the question is, hey, what if I wanted to get that into SQL Azure? And so if you wanted to move that into Azure SQL Database, you have a couple of options. You could go ahead and use something called Scoop, which is a project that moves from files that sit on the file system into a relational store. I've got, on the talk I did on Wednesday, I showed what that looks like in order to go do that. Or you could simply run it through your own process of pulling down the file from Blob Store, shredding it, and pushing it into Azure DB. That'd be the easiest thing to do. Is there another question over here? OK. Well, thank you very much. Enjoy the rest of the. Yes. HBase. OK. I would love to talk with you further about that. So we're certainly very interested in kind of rounding out the set of Hadoop components that we've got in the HDInsight offering. The exact timelines for when we'll roll out what and when, we're still working out. But when we've got something to say, you can expect us to talk a whole bunch about it. So, question here? So results will generally not get streamed back through the resource manager ever. Results will go from the individual nodes to the file system. And honestly, if you look at the way, if you implement something on top of it which streams results back directly, typically that's going to go from an individual node. Or you'll have a single dedicated node, like in Hadoop 1, you have a daemon that's running called Hive Server. All that's doing is that's a little bit of an RPC-style shim that goes, runs the jobs, and then streams it back from the file system, so that you've got like an ODBC-type JDBC interface. But it won't get streamed back through the RM. Yeah, so the question is, hey, how does this make Hadoop faster? And in a couple of ways. One, it actually allows for MapReduce to become substantially faster. It doesn't magically make MapReduce not a batch-oriented processing system. The interesting thing that it lets you do is bring non-batch-oriented processing systems on top of the cluster. So if you wanted to run something like HBase, which is much more interactive, you certainly can. If you want to run something like Tez so that you have substantially faster Hive performance, you can. And so it allows the deployment of things that aren't MapReduce, and so it lets you possibly do non-batch, more interactive type things. But Yarn in and of itself doesn't fix that. It simply enables the ecosystem to take advantage of that. Yeah, so HBase is an example of an app that can be deployed on Hadoop 1. You can also deploy it via Yarn. I was just using that as an example of that's an app running on Yarn, which gives you much more interactivity. And the reason that that's running on Yarn is what I mentioned earlier about almost using that as your bootstrapper installer, rather than having to spin up the daemons on every node. Yeah. What of this stuff could be installed on a Hyper-V cluster on premises? So the short answer is all of it. From the perspective of what we're doing inside of HDInsight is we're just deploying the Hadoop bits and the various Apache projects. The HDInsight service is not offered on-prem, and so it doesn't have a story for deploying to Hyper-V on-prem. But there's nothing which prevents you from deploying a Hadoop cluster that way. So we don't for HDInsight. We've got some guidance and some PowerShell scripts for deploying to IaaS running in Azure, which would be very similar to deploying to Hyper-V. I know the individual Hadoop vendors may, so both Hortonworks and Cloudera may have specific guidance. I know they have guidance around various hypervisors. Question in the back. Yeah, so question is, hey, how would we go about tuning the cluster? I would say right now it's somewhat of a dark art. There's a set of metric APIs that are on the cluster that you can call and consume metric results from in order to understand the various memory pressure, I/O pressure on the nodes. Right now, that's not all wrapped up in kind of a nice, pretty easy to use tool. You can imagine that's something we might be interested in doing at some point in time. Yeah. There's not right now. Yeah, one of the things that we've opted to do right now is that we don't surface that level of cluster configuration in the UX. It's there, you can do it in PowerShell. You can set all of the, hey, I'd like to set, java.default heap size, blah, blah, blah. You can set that at cluster creation time and go. But we don't surface that in the UX right now. Anything else? Okay. Yes? Okay. Yeah, so question is, hey, we've got a Cloudera deployment on-prem, trying to move to HDInsight. We're using Cloudera. We're using Impala. So right now, we don't offer Impala in the service. And so I'd love to follow up with you afterwards to kind of talk a little bit more about that. There are some options there. There's a big giant it depends. Okay, great. Well, thanks, folks.